Set yourself up for an interstellar stunner, because according to a group of scientists, Betelgeuse, the fascinating red supergiant adorning Orion's shoulder, has already exploded. That's right, you heard that correctly. We are not kidding. Within the next 10 years, or perhaps a couple of decades, its brilliant aftermath will illuminate the night sky. But how did scientists reach this conclusion? Should we be concerned? Can the James Webb Space Telescope capture the remnants of Betelgeuse? Today, we're diving deep into all the latest details. Betelgeuse is one of the most prominent stars in the night sky in the northern hemisphere during winter. It's among the handful of stars that shine brightly enough for us to see with the naked eye. Its reddish-orange hue easily distinguishable. Normally, Betelgeuse is the 10th brightest star in the night sky. But as you may already know, it has always been known to vary in brightness. Part of the reason for this is that Betelgeuse is by no means an ordinary star. Due to its enormous size, if we were somehow able to replace Betelgeuse with our own sun, it would stretch all the way to the asteroid belt and have a mass of an astonishing 20 times that of the sun. It may come as a surprise, but Betelgeuse is quite young for a star, with an age estimated to be around 8 to 10 million years. In comparison, our own sun is much older, with an estimated age of around 4.6 billion years. This is because supergiant stars like Betelgeuse burn through their nuclear fuel quickly and go supernova relatively rapidly on geological timescales. This also means they evolve quickly, and Betelgeuse may indeed have done that right before humanity's eyes. To understand how scientists concluded that Betelgeuse had already exploded, it's crucial to dive into the context. The story begins around the 2nd century BC, when Chinese astronomers made a significant observation. Betelgeuse exhibited a distinct yellow hue. Fast forward to the middle of the 2nd century AD, and the Greek astronomer Ptolemy described it as orangish or reddish, similar to how it appears today. Similarly, medieval observers in the Middle East noted a similar hue. The question arises about how colors were named or perceived in the past, but in this case, there's a physical possibility that Betelgeuse underwent a color change within a few centuries. It's possible that Chinese astronomers observed Betelgeuse during its yellow supergiant phase, and over several centuries, it transitioned into the red supergiant phase. Given that humans, by nature, are sky watchers, you have to wonder how many people around the globe saw the change, but left no records. After all, changes to a star like that likely came with all sorts of dimming and brightening events that aren't documented. Imagine people looking up at the night sky and saying, "Hey, didn't that star used to be brighter?" And that's exactly what's been happening right now. Betelgeuse is a variable star, but it seems to follow some cyclic behavior. Starting in December 2019, Betelgeuse's brightness unexpectedly dipped dramatically, which was noticeably visible to the naked eye for those accustomed to observing the star. It wasn't its usual self until mid-2020. Over time, it recovered, and one theory was that some of these cycles had coincided, leading to an especially deep dip in brightness. However, observations made by the Hubble Space Telescope revealed something rather curious. It appeared that Betelgeuse had expelled a massive amount of scorching material into space, forming a gigantic dust cloud. This dust cloud, in turn, obscured a large portion of the star's light when seen from our perspective. The change was quite astounding. Betelgeuse, once counted among the 10 brightest stars in the night sky, faded to the point where it ranked lower than the 20th brightest. It was truly perplexing to witness its dimness compared to its neighboring star Aldebaran, which holds the 14th position in terms of brightness. Fortunately, Betelgeuse showed signs of improvement, but its peculiar behavior didn't stop. In fact, it is currently exhibiting a state even stranger than simple dimming. Over the past few months, Betelgeuse has experienced a dramatic increase in brightness, surpassing its usual luminosity by a staggering 50%. This puzzling situation is quite unsettling for a star known for its changes. The dimming events could be caused by dust coinciding cycles, or perhaps the star developed large sunspots. However, a significant increase in brightness is an entirely different thing. Although it may be related to the previous event, when Betelgeuse expelled material in 2019, it likely caused a major disruption in the star's plasma flow. The current behavior we observe could be considered an aftershock of that expulsion. But what lies behind this unconventional behavior, surpassing the star's usual variability? One moderate theory that has been widely discussed is that Betelgeuse is approaching the supernova stage. While moderate estimates still suggest that the star is roughly 100,000 years away from a supernova event, we will provide evidence to challenge this idea and show that it may have already happened. So, what is the evidence? According to a remarkable recent scientific paper by Hideyuki and colleagues from Tohoku University in Japan, Betelgeuse has already undergone a supernova explosion, and we may be seeing the fallout of this infinite display in something like 10 years or a couple of very long years from now. Yes, that is right. As astonishing as it sounds, the last noticed cosmic explosion in our world was the Kepler supernova, which was as far back as the 1600s. Through a careful assessment of Betelgeuse's fluctuation designs, scientists have found 4 particular occasional changes happening at time frames of 2,200, 420, 230, and 85 days. While the beginning of the longest period remains obscure, it is estimated to be the crucial period, with the more limited spans possibly filling in as suggestions. The scientists propose a model suggesting that Betelgeuse is in a late phase of carbon burning, implying that it may be close to an awesome blast, situating it as a prominent contender for the next expected supernova event inside our Milky Way galaxy. In regards to unraveling the mysteries surrounding Betelgeuse, there's a bit of a puzzle. You see, there are some clashing perceptions regarding the emission of materials and the star's subsequent recovery. The overall consensus leans towards a mass ejection event, something not entirely unbelievable for various types of stars, although on a more modest scale compared to our own sun. But here's the twist. Supernovae are a real thing too. We actually saw one in a satellite galaxy of the Milky Way back in 1987. So, while it's possible that our estimates for Betelgeuse's explosion timing could be off, don't go planning a trip around it just yet. The tricky part is that Betelgeuse is currently difficult to observe. It has slipped behind the sun and won't be visible again until at least August. Consequently, we're left in the dark about what this cryptic star is up to right now. What we do know, however, is that it's kicking its usual patterns by brightening. Now, here's something captivating. Betelgeuse's gigantic size and relatively close proximity, roughly 650 light-years away, allow us to resolve a disk while observing it. Most stars are simply too far away, appearing as mere points of light. But with Betelgeuse, we have a rare chance to capture direct variations in its light output through photography. So, we not only have a star that could potentially go supernova, but also plenty of data to gather, including images, even though they may be a bit blurry. Let's imagine the scenario where Betelgeuse has indeed gone supernova. How might it look? First things first, it would be a real spectacle. But don't worry, it's entirely safe for us here on Earth. You see, Betelgeuse is far enough away that it won't harm our planet when it goes supernova. However, it won't be the brightest object in the sky. In fact, the moon will still outshine it by a long shot. And let's not forget about the sun. However, it would cast its own shadows at night and remain visible during the daytime for about a year. Now, here's the fascinating part. The supernova would be visible at night for several months, gradually fading. There might be a brief period where it regains some of its former brightness, but eventually, it will continue to fade until the familiar shoulder star in the constellation Orion vanishes altogether. While this supernova won't pose any danger to us, it could create some confusion. Certain animals rely on twilight for navigation, and with an extra bright light in the sky creating shadows, it could throw them off their game a bit. But that's not all. Astronomy itself would face some challenges. Observing the night sky from Earth during times when the moon is shining brightly can be tricky, and a very bright supernova would only complicate matters further. However, many telescopes would likely be more interested in capturing the supernova's magnificence than anything else, even if it means adjusting their observations. Additionally, there would be some warning signs before the visible blast, such as detecting neutrinos and gravitational waves from the star. But here's the big question. If Betelgeuse has already gone supernova, could we catch the remnants? For that, we need to wait for the James Webb Space Telescope to detect the supernova remnant. So, how long could it take for Betelgeuse to go supernova? We're not entirely sure, but it could happen as soon as next week, next year, or in 100,000 years. In cosmic terms, that's essentially the same as right now. After all, the light we see from this star is, in fact, very old, and if it exploded 600 years ago, we wouldn't know about it yet. What do you think? Could Betelgeuse have already gone supernova? Or is it just showing some surprising variability? Let us know in the comments. The James Webb Space Telescope is obviously the ideal instrument for making these observations. We shouldn't have to wait long before it solves the mystery once and for all. The mission to understand Betelgeuse's behavior and its implications for stellar evolution involves a complex approach, combining observational astronomy, theoretical modeling, and historical context. This star, famous for its variability and massive size, provides a unique opportunity for astronomers to study the life cycle of very giant stars and the phenomena leading up to supernovae. First and foremost, it's essential to understand the significance of a supernova in the broader context of cosmic evolution. A supernova isn't just a stunning event. Occasionally, it's a basic cycle in the life pattern of stars. These blasts assume a crucial part in scattering heavy elements throughout the galaxy. These elements, generated in the cores of huge stars, become part of the interstellar medium and contribute to the formation of new stars and planetary systems. Subsequently, the investigation of stars like Betelgeuse and similar stars helps cosmologists understand the chemical evolution of the galaxy and the mechanisms driving stellar development. Betelgeuse's impending or recent supernova event would mark an essential moment in this stellar life cycle. Researchers are particularly interested in the mechanisms that govern the transition from a massive star's final stages to its explosion. Current models suggest that as really giant stars like Betelgeuse approach the end of their lives, they undergo a series of complex processes, including core collapse and the ejection of outer layers. These stages are characterized by significant mass loss, which can affect the star's brightness and variability. By observing Betelgeuse's changes, scientists can gain insights into these processes and refine their models of stellar evolution. Additionally, the historical records of Betelgeuse's brightness variations and its recorded color changes offer valuable clues about its past states. However, early astronomers' observations, limited by the technology of their time, have provided a baseline for comparing current data. The change from a yellow tint to a reddish-orange hue over centuries could reflect the star's internal changes and its movement toward a supernova. This historical perspective enhances our understanding of how massive stars evolve and how their life cycles impact their surrounding environments. The potential for Betelgeuse to become a supernova also aligns with our understanding of cosmic events on a larger scale. For instance, the study of supernovae helps astronomers investigate the conditions leading to different types of explosions, such as Type 1 and Type 2 supernovae. Type 1 supernovae are typically the result of nuclear explosions in binary star systems, while Type 2 supernovae, like those expected from Betelgeuse, arise from the core collapse of massive stars. Understanding the differences between these events can help scientists piece together the history of our galaxy and the frequency of such occurrences. Observational challenges, like Betelgeuse's current position behind the Sun, highlight the complexities involved in studying such dynamic celestial objects. Despite these challenges, astronomers use various techniques to monitor stars that are temporarily obscured. For example, they utilize space-based observatories and specialized telescopes to track the star's light curves and analyze its spectral data. These methods provide essential information about the star's composition, temperature, and potential for a supernova. In addition to observational approaches, the use of theoretical models plays a critical role in predicting and understanding supernova events. Scientists create simulations that combine current observations, historical data, and theoretical physics to estimate how a star like Betelgeuse might behave. These models help in predicting the timing and characteristics of the supernova, offering insights into what observers might expect and how the explosion will affect the surrounding space. The ramifications of a supernova from Betelgeuse extend beyond the realm of cosmology. For example, a supernova of this magnitude would contribute to our understanding of cosmic radiation and its effects on Earth. Although Betelgeuse's distance ensures that it poses no threat to our planet, the study of supernovae adds to our knowledge of cosmic rays and their interaction with Earth's atmosphere. This information is essential for understanding space, weather, and its potential impacts on satellite operations and communication systems. Ultimately, the potential discovery of Betelgeuse's supernova remains a source of excitement and interest within the academic community. The event would not only advance our knowledge of stellar life cycles, but also captivate the public's imagination. The dramatic visual impact of such an explosion, visible for months or even years, would undoubtedly inspire a new generation of astronomers and space enthusiasts. Public interest in astronomical events often fuels educational outreach and promotes scientific literacy, emphasizing the importance of continued investment in space research and exploration. In conclusion, the possible supernova of Betelgeuse represents a significant milestone in our understanding of stellar evolution and cosmic events. The ongoing observations and theoretical work surrounding this star contribute to a broader comprehension of the universe's workings. As we await further data from the James Webb Space Telescope and other observatories, the study of Betelgeuse continues to provide valuable insights into the dynamic processes governing massive stars and their ultimate fate. Whether Betelgeuse has already exploded or is nearing that dramatic event, its story underscores the ever-evolving nature of our exploration of the universe and the continuous quest to uncover the mysteries of the cosmos.